Hello, my name is Ashish Shukla. Welcome to training for analytics visualizations in Oracle Utilities Meter Solution Cloud Service. In this session, we are going to talk about unaccounted for losses in Oracle Utilities Meter Analytics visualizations. For the capabilities covered in this training, we will give an overview followed by more details to explain how you can use these new features and the business value they provide. We will then walk you through a demonstration of this new feature, and lastly we will explain what you need to consider before enabling these features in your business and what you need to know to set them up. So what are maps visualizations analytics and what are their capabilities? Think of Meter Analytics Map Visualizations as a data-driven dynamic visualization tool which highlights important data trends and allows you to easily create a variety of interactive maps to present data and discover important insights for the business. This tool allows you to build various maps and visualizations. We have a rich library of maps that you can use, that you can copy and modify as required. The important thing is that we have already done the database works behind the scenes. So all you have to do to create maps is simply drag the attributes you want to use in the maps and the data visualizations are automatically there. You can also create custom maps if you have more specific needs. You can include various data layers like maps, charts, tables with which you can use to drill down to various information from global boundaries to zip codes to points of interest. Also, filters allow you to filter the data by particular types, category, and dates, and you can define multiple visualizations interactions to relate to another. You can see the data on maps which are become digital, interactive, and more appealing as they are incorporated with geographic like latitude, longitude, and detailed street views. So seeing location data mapped and included in visualizations allow more users to enhance their understanding and offer a valuable business insights through OUAV. The unaccounted for losses map provides more visually appealing graphics and an efficient way to analyze the areas affected by losses. Water utilities often have requirements to see the unaccounted for water or water leaks detection. Similarly, energy utilities often face terrible problems with theft. They need tools to help them identify non-technical unaccounted for energy losses. Map views help you to identify where water losses are happening. These can help you to identify which areas have most potential theft or gas leaks by looking at the geolocations and detailed street views. This also helps you to identify which areas are having the most non-technical unaccounted for energy losses by viewing different geospatial details. These losses are specified at the district meter areas or transformer level, grouping meters together and aggregate the data in MDM. Apart from this, you can do zoom in and out to view detailed geolocations up to street views and can perform quick identification of source of the problem. Now we are going to talk about the business value this feature provides. These map visualizations help you quickly identify where losses or leaks occur and can help you to analyze the unaccounted usage data using geolocations like latitude and longitude. They can also help you identify various patterns, orders, and spatial details and discover relationship of district meter, transformer to service points and dependencies between losses. This feature uses real-time map analytics. The heavy data can be shown quickly and easily through map visualizations along with geospatial data. You can create various map visuals for your data like heat maps, cluster, point, and more. Additionally, there is no separate data warehouse to maintain. Data comes directly from your production database, making it easier and cheaper to maintain. This demonstration shows you how you can use maps visualizations to enhance your business. Now let's look at top and under and over usage customers. Here in top and under, it filters all the under usage and provides the list of facilities ranked with under usage in percentage, along with facility address, city, postal code, facility ID, and facility service point ID. In the bottom here, we can see under percentage usage in a graph plot. In top N overusage, we have a similar, but it filters all the overusage percentage, or which is above 100% usage, and it lists the facility rank with top N overusage in percentage. Okay, so after top and under and over, now we can go for analysis to see the details. Here we show together under and over usage. And we can also select individual ones or row or individual facility to see it on the map and see the breakdown by service point. Here in map we can see a particular facility and connected downstream service points located here by other details. In right side, we can see the downstream usage in tabular format. If you want, you can select the particular service point and similar to see the physical location in the map with other details. Now we can go to the facility charts to see the relationship of usage between facility and downstream service points. Here, basically we are comparing the facility usage or average usage, which is an absolute value, and the average value of all the downstream service points usage which are connected with a particular facility. Here, basically it's a graphical relationship of individual service point usage in compare with related facility usage. You can determine how the individual service point is far enough from average usage. In this facility map, we can see how service points are mapped with facility, or the number of service points are mapped with individual facility ID. So for an example, here you can also see or analyze that might be there is a mismap between facility and connected service points, since the distance between facility and connected service points are too far to exist in real scenarios. In this section, we provide implementation considerations and setup instructions for the enhancements covered. Maps require actions to be performed before they are available to users. The maps can be accessed through standard Oracle utility analytics and visualizations and access mode functionality. Typically, your administrator will grant access to specific user groups such as metering, billing, etc. The business processes associated with this feature are unaccounted for water, unaccounted for energy, unaccounted for gas, and users can drill back to service order management and issue manual fieldwork based on findings. Implementation considerations include: for data to appear on the maps, service points must contain geographic latitude and longitude. This feature requires metadata management dynamic aggregation be run to summarize the usage for each service point. Datasets query MDM aggregated values. Users can use demo examples or build their own. Users can use the provided values or build their own. To configure or create maps visualizations, user must select the map type of category. Maps require the selection of appropriate datasets to create and access visualizations record. The autofocus on data field needs to be set to on, and the background map field should be set as OpenStreetMap for detailed street views. This concludes the presentation. Thank you for listening. You can easily pause and rewind any of these slides if you require additional time to take in the detail.